Hello, everybody. From discovery to integration, how we elevate monitoring for Kabelplus. So we will show you how Kabelplus customized their Checkmk in order to elevate monitoring in order to provide maximum transparency for support teams. To do this, we will talk you through our enhancements. We share practical solutions and discussing challenges faced during implementation. But first to us. This is Stefan from Kabelplus, and I'm Mathias from Iteratio. So, who is Iteratio? So, it was founded 2001 by Rolf and Hardy, sitting in the back somewhere. Hardy you might know from the Conference 9, where he gave the pretty famous talk, monitoring of very large infrastructures, which was the beginning for the network topology maps within Checkmk. The core competence of the company is network and system management. It is working since 2012 with Checkmk. It is since 2014 partner, and it's an award-winning partner and a gold partner, of course. About me, not much to say. I started 2017 to work for Iteratio, and before that, I basically studied physics, working as a scientist, and then switch the industry, basically. But now to Stefan.
Thanks, Matthias. My name is Stefan Novak, and I work for the Kabelplus company, which is mainly an internet server provider in East Austria. So we founded in 1978 as a typical cable TV operator, and then we expand our services to our internet customers in 1997. So our journey with Checkmk started in the summer of 2023 with the installation of a hardware cluster in our data center. And after a comprehensive testing and implementation phase, we successfully migrated from our legacy Nagvis environment in January 2024. So now 2 sentences about me. I worked in Kabelplus 10 years as a typical system operator, dealing with VMware, Linux servers, and data center network. And after that, I changed to the IP network operations team, where I'm now responsible for the Cisco MPLS backbone, the internet peering services, and of course, the monitoring of our whole network. So my personal experience with Checkmk is now 10 years ago. I started with some small projects for myself, so I currently monitor my smart home solution in my own house with Checkmk. So now some facts about the Kabelplus. We currently have around about 130,000 customers. 123,000 also subscribe to an internet service. Approximately 20% of them are already connected with fiber to the home. And we handle approximately 300 gigabit peak traffic to the internet on a daily basis. So now let's talk quickly about our Kabelplus Checkmk environment. We currently have 4 sites. 2 of them are connected on the hardware cluster to keep the system at most independent from the rest of our network. Then we also operate a virtual appliance in our VMware infrastructure to distribute the monitoring load more efficiently. And we also host 1 site in Germany at the Hetzner Cloud that we can get some external view of our network from the internet side. So we currently monitor around about 4,200 hosts with 100,000 services. And as we are the network department, it's mostly SNMP out there. And these numbers are rapidly growing since our network is rapidly growing. So now in our presentation, we will show you 3 problem cases where we have to develop our own custom solutions. And the first thing we want to show you is how we manage our host inventory and how we use geolocation to quickly localize outages. So all our hosts are currently managed in an IPAM database. So to prevent redundant manual work and to ensure consistency, we implemented an automatic provisioning from the IPAM database to the Checkmk. So if we insert some hosts there, they get inserted into Checkmk and updated also. So we also want to enrich our hosts with some geolocation data. So for some hosts, we already have the geodata in our IPAM database. For other hosts, we just have the postal address in the SNMP location field in the network device. So we have to get it and translate it into geo coordinates. So why we want to do that? Because we want to use some visualizations on some Nagvis maps for our technical teams that we can, that when we have some power outages or some digging work, we can have some fine maps where you can see there's red, so there must be something fault in this area. And so now Mathias will walk us through how he implemented the solution for Kabelplus.
Okay. As Stefan already said, we provisioning hosts from PHP IPAM via the API to Checkmk. Then we enrich the data from the host, which could be the address and some other informations, by using SNMP. Yeah, we are asking this famous ORD, or we're using the system description ORDs in order to get know which device we are talking to. And such devices, like Huawei something, are then automatically recognized, tagged, and placed in the according the folder structure. For some hosts, we have addresses. For some hosts, we have coordinates. These two attributes are maintained for each host in so-called custom host attributes, as you may know. But since Nagvis is just dealing with geolocations, we need to look up the geolocation for the host, which we only have addresses. For that, we're using the Google Maps API, so that we get all the hosts provision correct. One additional thing was, or one challenge was, Stefan should not be the only contact person. So these different devices are also corresponding to different teams. And of course, if the data is not correct, the corresponding team should be alerted. So with all this information now in our head, we simply started to provision all the hosts to Nagvis. Technically speaking, this means we're using the Nagvis word map and writing the SQL database from Nagvis itself. So to say, it's a very accurate representation, as you might see on the right-hand side. This is an image from the host. Of course, you could more zoom in, but we were not allowed to do that here. But this works very well. In order to tackle these two teams, so that each team only sees their devices, we basically use host groups to differentiate between. As far as I heard from Stefan, that these informations are all pretty helpful in such root cause analysis when there is a power outage or digging work or whatever. Okay, now we have all the hosts within the map and in Checkmk, but sometimes addresses changes. Yeah, a device goes to a different location. How to refresh this data? We are basically using the hard and software inventory for this. Yeah, we're using the information from there and update each device accordingly. Yeah, but now back to Stefan.
Yes, thanks, Mathias. So now that we have all our hosts integrated into Checkmk, the next challenge for us was to ensure that the alerts we are generating are delivered to the right technicians at the right time. So the first thing what we are thinking about when we are going to notification is that networks can be unusable. So we still rely on the old SMS for very, very critical messages. So we also want some redundancy in the system, so we installed two GSM modems and two different network operators, and we also have to ensure that the SMS where we send it out is always going out there. So, and the third problem we face is we have several on-call technicians teams. Sometimes they are 24/7, and their shifts change 3 to 4 times a week. And so we want to have a simple, secure, and fast way to notify the right technicians. And we think that changing the notification rules in Checkmk every time for every technician is not the right solution for us. So Mathias has to provide us with something better for us.
Yeah. So what we did is basically, first of all, what kind of devices we are talking about. These are basically these which are shown in the image there. They're from the hardware group, SMS Gateway 3, they're called. So when you're starting with that, Checkmk does not know anything about this device. So first of all, we're starting developing a notification plugin. Okay, it works with the both modems and also has a redundancy built in that is whenever a modem is not reachable, it connects to other modem. Okay, now you have a notification script. What is the next step? Of course, you want to monitor these devices. How long is the queue length, how is the cellular connection, and so on. This we also implemented. Now to the last and more difficult task is basically to have a GUI implementation or a simple way to configure the notification for the technician. So how we do that? You see this example here on the right-hand side. This is basically a GUI within Checkmk we built. It reads the configuration automatically, which means each user with a phone number and contact group membership are read automatically with the Checkmk informations. Then, of course, you can deselect and select different users. For that, we have to think about how to get a notification plugin in order to work with that. We're basically using some small configuration file. So we have to extend the notification plugin a little bit. And of course, since this GUI is only on the master side, we have to also think about distribute this config file to all sides. And whenever you click on Save now, this config file is then distributed. Of course, there are some checks. So it cannot be that there is not a contact group which has no selected user. So there has to be at least one user selected. Of course, you can always test the SMS, which basically means that we have certain dummy hosts which then get a fake check result and trigger a notification. This triggering a notification was also a task that each day, I guess at 7 o'clock in the evening, there should be a regular job just triggering a test notification. We also implemented that. This GUI itself is not dependent on any value spec or form specs, technically speaking, so it supports the current Checkmk versions. One small thing we want to add in the next couple of weeks is basically an automatic refresh of this page, because sometimes, Stefan taught me, a technician open this page, leave it open, and after a week or so want to save his configuration, and then this configuration is different till then. Now back to Stefan, to our last.
Yes, thanks, Mathias. So the third challenge we face is currently managing our large network. So as we have many devices and many network interfaces, we don't want to reconfigure our Checkmk environment every time something is changing there. So what we decided to do is we want to configure our monitoring directly on the device, since we are network operators and we just want to configure network devices all the day. So we just invented a naming convention for interface descriptions. And from these interface descriptions, we generate a wide range of service labels, and then our completely Checkmk configuration is based on these service labels for alerting or just for some alarms generated. And we also have some customer IDs in our network interface descriptions. So we also want to generate service labels out of that we can have a dashboard for our support team. So now I have a little example of what we are exactly doing here. I've highlighted some of our tags. So here you can see the interfaces with interface description. And we have a tag called monBB. That's for us, it's a backbone interface. And we sure have to monitor this one. And we also have here a tag with an alert of 4,800 megabit. So maybe we just have there a 6 gigabit backhaul connection, and we want to get an alert when we have to upgrade it to 10 gig or something better than that. And on the second interface, you can see there's a tag called IIS. It's from our management system. It's automatically provisioned. And you also have there the customer ID. And we also want to generate some dynamic service labels with the customer ID and also some static labels like this is just an FTTH customer port. And now go back to Mathias, how he programmed this all for us.
Yeah. Oh, sorry, I was one. So, okay, first of all, as you might see down below, there's the example from the page below, or it's the same example. To gather this information and put it in service labels is not manageable or not doable with normal Checkmk discovery rules. Yeah? So you cannot say, hey, I have a certain tag, IIS, and then the value which is after that, I want to have as a service value or service label value. So, as we first started, we basically wrote a script which first gets all the interface descriptions, and with a certain pattern or a pattern definition, as you might see on the right-hand side, you can basically select which you can select via regex which group or which value you want to have as a certain value. Yeah, so you can make something like customer and then the first regex group as the point under custom keys. Of course, you can ignore values, yeah, because sometimes this automatism wrote there IIS none or null or whatever. You can ignore these if you want to. And of course, like in a normal discovery rule set, we wanted to write something like, okay, if this description matching, we want to have this and this service label. So with all this information, we looked up, and we coming to something around 20,000 labels. So now we have this 20,000 labels. How to get them back into Checkmk and to set them to the individual devices? The first idea we had, like always, using the REST API. Okay, you can of course write rules with the interface and switchboard discovery rule set, or you can write rules with service labels directly, but this is not usable. So for instance, the GUI is not responding anymore if you have 20,000 rule sets, or you cannot, it's not transparent to work with that anymore. So this was not a good solution. Then, to our mind come, Checkmk does work with all the small MK files in the configuration. So we write basically own MK file, which work, of course. But in the productive environment with this huge number of labels, we're ending up with an MK file with around 5 megabyte. And if you then wanted to activate the core, it takes around, so after 5 minutes, we abort this whole thing. Yeah? So this was not a real solution for that. So what we do then is basically, since it's all interface-related stuff, we basically hijack the interface check. So we're simply loading all our labels information into the service discovery of the interface check, and we're done. Yeah, this works perfectly fine. And of course, you can also use the standard switchboard and interface rule sets in order to add labels or whatever. One downside of this, one issue with that is basically that you have a small text file which you have to sync to all of your sites. But for this, we have already with the SMS solution some things in place. So how we did that, a more technical thing, we appended some lines into the standard interface check. One, we have basically a function which basically say, hey, please get me from this certain file and this item and this host name, the labels you have, and of course extend the, and for that we need the host name, of course. And you see then in the green area in the door, the one below, that we simply add the labels to the corresponding labels you're already getting via the switchboard interface discovery rule set. So these small modifications we had to deliver, but since they are so small and I would say it's not dependent directly on a Checkmk version, you only need to do this few modifications each time you update. With that, this works. So we managed to do 20,000. We managed to set this 20,000 labels, and as you might see on this side, there's basically a dashboard for the support where they can simply filter for each customer. And the technician directly sees the relevant graphs, the relevant services, and can see directly the issues related to all of that. So let me a little bit sum up. So we're provisioning the devices from PHP IPAM, enrich the information, and put them on a map in Nagvis in order to see everything and helping a little bit with root cause analysis. Then we implemented some notifications, built a custom GUI around that in order that the technician can do changing the shifts and changing the person who's in charge. And to last of all, we showed you the service labels and how Kabelplus does dynamically configure the Checkmk. And of course, with all of that, how to set these 20,000 service labels. Now the big question is how you can benefit of all of that. So we are thinking a little bit about that. So of course you can contact the company, so Iteratio, you can contact us. We can help you with provisioning stuff, because this is not a general thing, so to say. You can the notification plugin and of course the monitoring plugin. If you're using the same modem, you can look up in the Exchange. We put it there. You can benefit from the code. For the service label things, we have a Git repository from the company Iteratio, where I put basically all of the scripts and of course also the SMS GUI thing. If you want to build your own web page within Checkmk, you can use this as an example or use it as a starting point for your own things. And feel free. And to last of all, we have to say thank you for your attention. When you have questions, you can also email us. So our both emails are written there. And thanks for your attention.